Alright, so today we're going to be going over the chain rule. So the chain rule is another way of deriving a function. So the formula for it is f prime as a function of g of x multiplied by g prime as a function of x. So if we visualize that for a second, so let's say g of x is equal to g of x is the inside function, and then f of x is the outside function. So if we visualize that here with radical x squared plus 1, let's say x squared plus 1 is equal to g of x, and the radical is f of x. So f as a function of x, we would write this as x to the 1/2 power, which x would equal, or actually let's use u. So let's say u equals x squared plus 1. It would be u to the 1/2 power. So we would write it as u to the 1/2 power, in which now we're going to find the derivative of u, and we're also going to multiply that by g prime, which is x2 plus 1. So g prime is going to be 2x. So we have the derivative of g. We need to find this part in the front. So u to the 1/2 power, if we bring it to the front, we would have 1/2. U to the negative 1/2 power, and times 2x. Now u is equal to x squared plus 1, so now all we need to do is just plug it in. So we would have 1 over 2 radical x squared plus 1, because negative 1/2, u to negative 1/2 power means that's in denominator to the 1/2 power, which means that it's still in a radical, times 2x, which you could put 2x in the numerator as well. But this is how you'd use the chain rule to get this derivative of x squared plus 1. It's much easier than using any other rule. And let's say we have d over dx, x squared plus 3x plus 5 in parentheses to the power of 75. Now using like the product rule, the power rule or something would be basically impossible, because you would have to multiply this out 75 times, which is not possible. So by the chain rule, this is f of x, the outside function, x to the 75th power, or u to the 75th power. Now x squared plus 3x plus 5 is going to be g of x, our inside function. So we use this formula right here. Let's say u is equal to x squared plus 3x plus 5. So we would have u to the 75th power, and if we d over dx, if we find derivative of that, that would be 75 u to the 74th power. So our first part, which is f prime gx, is going to be 75 u to 74th power multiplied by g prime, which is g is going to be the inside function, x squared plus 3x plus 5, which is going to be 2x plus 3 for our inside function. Now if you plug in u, it would just be this would be u if you plug it in. We could do it down here. I don't think we'd have enough space. But if we plug in u, we'd have 75 open parentheses x squared plus 3x minus plus 5 to the 74th power multiplied by 2x plus 3. So that is the derivative of x squared plus 3x plus 5 to the power of 75, without having to multiply out anything, use any other rules. With the chain rule, it was just much faster and a lot cleaner, actually. Alright, so let's move on to these questions here. So we're going to be using the chain rule for all of this. So for number 1, we have y equals 5 minus x to the 4th power all to the 3rd power. So for the chain rule, we're going to set let's write out the chain rule here. F prime g to the power g to the function of x times g prime of x. It's a little bit congested there. So let's say the 3rd power here is fx, and let's say f minus x to the fourth power is g of x. And let's also make that equal to u. So let's say, if we substitute u in there, it would be u to the power of 3. And then multiplied by, we could also say u prime. We don't have to say g of x for this. So u to the power of 3 times u prime. So u to the power of 3, if we find the derivative of that, that would be 3x squared. And then multiplied by u prime, we know that u is 5 minus x to the fourth power. So we'll have the derivative of u is going to be negative 4x to the third power. And this should be u as well. That should be u. This stays as negative 4x to the third power. So we plug in u, or fill in the equation for u. It's going to be 3, 5 minus x to the fourth power to the second power multiplied by negative 4x3. And this would be your final answer. You don't have to multiply out anything. This would be your final answer by the chain rule. So now number 2 is y equals square root of x3 plus 2. So this is a half power, the square root. So we could say x3 plus 2 is going to be our u. So this is going to be u to the half power multiplied by u prime. So we find a derivative of that. That would be half u to the negative 1/2 power multiplied by u prime, which is x squared plus 2, the derivative of that, which would be 3x squared. And now if we plug it in, this u to the negative 1/2 power, which would be in the denominator, radical u, essentially. So if we write that, it would essentially be 1 over 2 radical u. So if we plug in the equation, we would get 1 over, we could also put 3x squared on the top, 1 over 2 radical x to the third power plus 2. And this would be your final equation. So for number 3 here, we're dealing with sine, cosine of x. So what we're going to do here is cosine of x is going to be our inside function and sine of x is going to be our outside function. So what we're going to need to do is, this is actually f of x and this is going to be g of x. So first we need to find the derivative of f of x, which is going to be cosine. It's not going to be cosine of x because sine of cosine x. So it's going to be cosine of cosine x because the inside is not going to change because g of x doesn't, it stays like that. Multiplied by g prime of x, which is the inside function because it's g of x. So inside function is cosine of x. The derivative of that is going to be negative sine x. And let me circle it out here so it's identifiable. So that is going to be your answer for number 3 using the chain rule. Now number 4 is something similar. We're using trig functions here again. So this is going to be f of x because it's the outside function. Inside function is g of x. So f prime of x is tan, the derivative of tangent is going to be secant squared, not x. Secant squared x squared, because the x squared, the inside stays the same, multiplied by g prime of x, which is going to be the derivative of x squared, which is going to be 2x. Now that's why, let's say we're finding the derivative of tan x. If you use the chain rule, you'll still get secant squared x, because by the chain rule, we would find the derivative of the outside function, which is secant x, secant squared x, multiplied by derivative of the inside function, which would be x. Derivative of that is 1. And secant squared x multiplied by 1 is just secant squared x, which is also the derivative by just the trig functions of tan x. So you can always use the chain rule to double check whether the derivative you memorized matches up. So yeah, you could just leave your answer like that, or you could write it out as 2x secant squared x squared. And that would be your final answer. And now number 5 is e to the power of radical x. So for this, we could set e as the outside function, and then radical x as the inside function, which is g of x. So the outside function we know that e to the radical x power, or rather e is just the derivative of e is e. So we keep e the same, and then radical x stays the same up here. E to the any x power is going to be, derivative is going to be e. And that's because e is a constant, and to the any x power it's going to be e, but e alone is going to be 0 because it is a constant. So we have e to the radical x power multiplied by g prime of x, which is gx is going to be radical x. So it's going to be x to the 1/2 power d over dx, because we haven't derived that yet. So when we derive x to the 1/2 power, we would get 1/2 x to the negative 1/2 power, where if we write it out, we get x to radical x. So the final answer would be e to the radical x power multiplied by 1 over 2 radical x. And that would be your final answer. You could also put e to radical x power on the numerator. That also works. And now number 6 is y equals e to x power plus 1 to the 1/3 power. So the 1/3 power I said because it's square root and then 3 over here. So what we could do is 1 over 3 could be our outside function, and then ex to plus 1 could be our inside function. So what we would do here is find the derivative of the outside function. We bring 1/3 to the front. 1/3. Let's say u is equal to ex plus 1. So 1/3 u negative 1/3 minus 1 is going to be 2/3. So 1/3 u to a negative 2/3 power multiplied by g prime of x, or rather u prime. Ex plus 1, the derivative of that is going to be e to the power of x. So now if we write it out, we would get 1 over 3 to the u to the 2/3 power on the denominator multiplied by e to the power of x. And now if we plug in u, let's create a line right here. If we plug in u on the numerator, we get ex, and then on the denominator, we would get 3 radical, and we plug in e to the power of x plus 1 for u, ex plus 1 in parentheses squared to the 3rd square root, or 3rd root actually. So this would be your final answer right here by the chain rule of number 6. Alright, so I want you guys to try number 7, 8, 9, 10, 11, and 12. So you could pause the video and try that. All these will use the chain rule, but you could also use the quotient rule for these two. But I would suggest using the chain rule, as it's a lot faster. So you could pause the video and try them out. Alright, so for number 7, we're looking at function x is 2x to the 3rd power minus 5x squared plus 4. And all that is to the 5th power. So what we did at the start, we would, this would be our outside function. Let's say u to the 5th power. Let's say u is 2x to the 3rd power minus 5x squared plus 4. So let's say this was our u. So u to the 5th power would be, if we rewrote it, multiplied by u prime. So now if we find the derivative of that, that would be 5u to the 4th power multiplied by u prime, which is 3x, or not, rather 6x squared 6x squared minus 10x. And yeah, that would be our u prime. And now what we need to do is just plug in u and we have our answer. So 5 open parentheses 2x3 minus 5x squared plus 4 to the 4th power multiplied by 6x squared minus 10x, and that is our final answer. I couldn't write it in one line, but that's our final answer for number 7. For number 8, we have to do something similar, except this one's to the 50th power. See, if we multiplied it out, it really wouldn't be possible in less than a few days to answer this question. But if we make the inside function equal to u, and exponent of 50 would be the outside function, we would have u to the power of 50 multiplied by u prime. So if we rewrite that out or find the derivative, we would have 50 u to the power of 49 multiplied by the derivative of u, which is going to be 5x to the 4th power plus 6x minus 1. And now if we plug in u, we would have 50 open parentheses x to the 5th power plus 3x squared minus x to the 49th power multiplied by 5x to the 4th power plus 6 minus 1. And this would be our final answer for number 8. And now number 9 is 5x plus 1 by a square root, which we could also substitute it as a half power. So for this, if we say 5x plus 1 is u, because it's the inside function, we would have u to the half power multiplied by u prime. So now if we derive it, we would get half u to the negative half power multiplied by u prime, which is going to be just 5. And now if you plug in u, we would have, we could actually put 5 on the top, 5 over 2, and this means radical u, which is radical 5x plus 1. And this is our final answer for number 8, or number 9 rather. So number 10 is one of the questions that you could use the quotient rule for, but I really wouldn't suggest it if you don't want to waste time. But so since there's nothing on the numerator, we could say that we could rewrite x squared minus 1 as, so it would be 1/3 on the bottom. If you move it to a numerator, it would be negative 1/3. We could rewrite it as x squared minus 1 to a negative 1/3 power. So now it's a lot easier to find the derivative. So if we say x squared minus 1 is u, we would have u to a negative 1/3 power multiplied by u prime. We find the derivative of that. That would be negative 1/3 u to negative 4/3 power multiplied by u, which is x squared minus 1, which is just 2x. And now we have to plug in u, which we might skip number 11 just because of space purposes. But if we rewrite number 10, what we have up here, we have negative 1 over 3, and then we could do 4th root x squared minus 1 in parentheses to the 3rd power multiplied by 2x. So essentially this is on the bottom x squared minus 1 to the 3/4 power, or actually no, it should be to a 4/3 power. Yeah, so 4 should be in here and then to the 3rd root. And that is multiplied by 1 over 3. And it's in denominator because we want to make it a positive exponent multiplied by 2x, which is derivative of this inside function. Now we're going to skip number 11. We're going to go straight to number 12. So number 12 is f as a function of t And in parentheses, we have 1 over 2t plus 1 to the 4th power. So for this, we can't exactly use 2t plus 1 as our, we can't rewrite it as a negative exponent function to make it easier, because this fourth exponent has to be our outside function. So this is going to be u. This whole thing is going to be u, so what we'll do is u to the 4th power multiplied by u prime. So now if we find the derivative, we would have 3, or no, not 3. It would be 4 u to the 3rd power multiplied by u prime, which for u prime, we have to use the quotient rule now. And the quotient rule, if you remember, is f prime times g minus f times g prime over g squared. So this question is going to get a little bit messy, but so f is on the top and then g is on the bottom. So if we started out, we would have f prime, which is 0, 0 multiplied by g, which is 2t plus 1, minus f, which is 1, times g prime, which is just going to be 2, and then over 2t plus 1 squared, that is. So now we know 0 multiplied by anything is 0. This is going to be negative 2. So if we rewrite everything and plug in for u, we would have, let's isolate this a little bit. We would have 4, 1 over 2t plus 1 to the 3rd power. So we plugged in for u, we plugged in this whole thing. And then that would be multiplied by, okay, that'll be multiplied by negative 2 over 2t plus 1 to the 2nd power. Now, you don't have to simplify out that denominator out, but yeah, that would basically be your answer for number 12. So you see, number 12 is one of the first questions we faced that we have to use more than 2 rules. We'd have to use the chain rule for the outside stuff, and then inside we had to use the quotient rule to get the derivative of this inside part. But if you keep it organized, it'll work just fine. But yeah. Alright, so now for these questions, I want you guys to try number 21, 23, 24, 25, and 26. So you could pause the video and try them out. Almost all of these some of these will use more than one rule, but I think about these two here will use chain rule. This over here will use the chain rule as well. This is the quotient and the chain rule. This is the product and the chain rule. So you could try them out. So number 21 is f of x, 4x plus 5 to the power of 3, x squared minus 2x plus 5 to the power of 4. So in order to find the derivative, we have to use the overall, we have to use the product rule and then the chain rule for the individual functions here. So if you remember, the product rule is f times g prime plus f prime times g. So if we write it out, we have f is going to be this one right here, g is going to be this. So we write it out, we have 4x plus 5 to the power of 3 multiplied by g prime, which is going to be, so g, in order to find g prime, we're going to have to use the chain rule here, which if we remember, outside function to the 4th power times derivative of inside function, which we're just going to kind of speed run it. So it's going to be multiplied by 4x squared minus 2x plus 5 to the 3rd power multiplied by derivative of the inside function, which is going to be 2x minus 2. And then, and then that's going to be added on to f prime times g. So f prime is going to be 3 open parentheses 4x plus 5 to the second power multiplied by the inside function, which is going to be 4, and then multiplied by g, which is just going to be x squared minus 2x plus 5 to the 4th power. And this long function here would be your answer. You don't have to simplify out anything, you can just leave it in this form, and that would be totally correct. So that was with the product rule and the chain rule. Number 23 is with the chain rule and the quotient rule. So for this, we use the chain rule first actually for the whole thing. So radical is also known as the power of half, and we could use this as our inside function. So we'll just do u to the power of half multiplied by u prime. And if we find derivative of that, that would be half u to negative half power multiplied by u prime. So u prime would be a derivative of this. In order to do that, we have to use the quotient rule now. So the quotient rule, if we remember it, it's f prime g minus f times g prime over g squared. So f is going to be the top, g is going to be the bottom. So f prime is going to be 1 multiplied by g, which is going to be x plus 1, minus f, which is x, and then times g prime, which is just going to be 1 over x plus 1 squared. Now, if we plug in everything and, plug in for u and then simplify this, we would end up with 1 over 2 square root x over x plus 1, and then, because that's to the half power on the denominator, multiplied by x plus 1, that would, on top it would be x plus 1 minus x, which that would just leave us with 1, multiplied by 1 over x plus 1 squared. So you can kind of see there's nothing on the numerator, there's everything on the denominator. But this will be your answer. You could also, of course, combine the two fractions together. But now for number 24, this we just use one rule, the chain rule. So this is the inside function. To the power of 5 is the outside. So we do u5 multiplied by u prime. Now if we find derivative of that, that would be 5u to the power of 4 multiplied by u prime, which is, since they're not being multiplied, so it's not the product rule or quotient rule, we just find derivatives independently, which would be 1 plus the derivative of 1 over x, which is 1 over x is also x to negative 1 power. So derivative of that would be negative x to the negative second power. And now all we have to do is just plug in for u. So if we plug in for u, let's do it a little bit up here. So we would have 5 open parentheses x plus 1 over x to the power of 4 multiplied by negative, that would be negative 1 over x squared. And that would be our final answer. You could, of course, you can't actually put together the fractions, but yeah, in that form, that is the simplest answer you could actually put it in. And now for 25, we're dealing with an e variable, or e rather. So for e, for this, our inside function is going to be this exponent, our outside function is going to be the e. So for this, we're going to have e tan theta, and because we have to find derivative of e to the tan power, multiplied by the derivative of the inside, which is tan, and derivative of that is secant squared theta. And now e to the anything power really is just going to be e to the anything power, or rather, if you want to get technical, E to the 10 power, derivative of that would just be ln E multiplied by E10, Beauty's chain rule for that, multiplied by secant squared theta. And ln of E is just 1, so that's why we don't regard writing that anyways. So you would just be left with E10 theta, e to the power of 10 theta multiplied by secant squared theta, and that would be your final answer. Now his final one is 2 to the t to the third power. So this is one we haven't seen before. So for this one, what we're going to do is this is going to be the inside function. 2 to the t power is going to be our outside function. So we're going to have 2t to the third power multiplied by the inside function, which is going to be 3t squared, or derivative of the inside function. So derivative of the outside function is going to be ln 2 multiplied by 2t to the third power. So that's the derivative of this part right here. And we found derivative of the inside, which is this right here. So we put both of these together right here. We would have ln 2 multiplied by 2t to the third power multiplied by 3t squared. That would be your final answer. So you could see ln 2 here actually plays a part. Instead, over here, when we have e, we just don't bother writing it out because ln of e is 1. But ln of 2 is not 1, so we have to include her in our answer because it makes a difference. So that's basically for number 26. And I hope you guys understood chain rule. And chain rule, a lot of the time, is personally, it is my favorite rule to use. Just because how simplistic it is, how fast it is. The quotient and the product rule become like a space-consuming activity, and the chain rule definitely becomes the best way to find derivatives, and especially when you get into like complex equations. But yeah, always remember the inside and outside function rule, and then how to differentiate both them, as well as the negative exponent, where to take that. And yeah, whenever you see a problem like this, don't let it scare you. It's chain rule makes it so much easier to look at. Yeah, it's basically it.